Well, hello fellow YouTubers! Welcome to G-Tech. In this episode, we're going to be powering up the Carver C-500 and testing it. Let's get into it.
Warning. Do not attempt this project unless you are experienced with electrical circuits. Serious injury, property damage, and even death can occur with this wire.
Regarding powering up the amplifier, the service manual under Test Procedure .2 states, plug line cord into a variable line transformer, aka variac, and slowly turn it up to the required line voltage, 117 or 230 volts. Let's pause on this for a second. Today, power companies have increased the line voltage from what used to be 117 to 120 volts or higher. Here at my location, I average 123 to 124 volts. Continuing in the manual, watch for any evidence the amplifier is drawing current from the line. Observe current meter if variac is equipped. My variac doesn't have a current meter, therefore we'll be using the incandescent current limiter we built in episode 2. Set variac for full voltage, 100% line. Verify that the leftmost LED segment is lit after 30 seconds. I have already plugged the amplifier into the variac and also have a voltmeter connected to accurately measure the line voltage. Let's turn the variac on and slowly bring the voltage up to 120 volts. We have 40 volts, 60 volts, 90 volts, and now we're at 120 volts. As you can see, the light bulb is lit dimly. This is normal. Had there been a problem in the amplifier, it would be bright due to a short somewhere in the amplifier. As per the manual, let's check the LED VU meters and see if the left LEDs are on. As we see, they are. Another thing we want to check is offset. According to the service manual under the same subheading, C500 test point number 7 states, measure across the output terminals of each channel for presence of DC voltage and verify plus or minus 10 millivolts or less with no inputs connected to the unit. As we see, the left channel has 2 millivolts and the right channel has 5 millivolts. Obviously, these parameters are well within spec. Now, let's get into setting the bias. In the service manual, point 3 under C500 troubleshooting states, to set bias, first warm up the C500 at 2 kHz, 1 watt into 8 ohms for about 60 seconds. Remove all input and output connections and measure the DC voltage drop across the output emitter resistors, 100 ohm per 1/2 watt, between output terminal bus and emitter of RCA 410 positive driver transistor, each channel. Let's stop right there for a moment. Measure the DC voltage drop across the output emitter resistors, 100 ohm per 1/2 watt. I'm not sure what they're talking about. However, the 2 points to measure are then mentioned, between the output terminal bus and emitter of RCA 410 positive driver transistor. Let's take a look at the output section of the schematic. We see that the positive side of the power supply bridge rectifier goes to the collector of RC410 on the left channel. We also see the emitter of that transistor connected to a 10 ohm 1/2 watt resistor, which in turn is connected to the output bus. What they are stating is to connect to these 2 points, basically across the 10 ohm resistor. So we have our 2 points to connect the voltmeter to on the left channel. Now, let's take a look at the right channel. We see the same positive side of the bridge rectifier going to the collector of RCA 410 of that channel. Again, there is a 10 ohm 1/2 watt resistor connected to the right output bus. So now we know that it is the same connection points regarding the right channel. Now the collector of a TO3 transistor is connected to its case. All we have to do is connect the negative probe of the voltmeter to the neutral of the power supply rail and touch each case with a positive probe to find out each RCA 410 positive driver transistor. The output stage consists of 2 rows of 6 output transistors and 2 RCA 410s, one for each positive and negative side of the supply rail. These transistors are at the very bottom of each row of output transistors. The left channel RCA positive transistor is at the bottom nearest the power transformer. The right channel RCA positive output transistor is at the bottom of the second row from the other end. Now we have identified the transistors needed to adjust the bias. If you look at the schematic again, the emitter of RCA 410 is connected directly to the base of all 3 output transistors in that row. That is indeed the case physically looking at the output section on the amp. That will be where we will connect the positive meter probe. Take note of discrepancy in the schematic. It shows that there are 4 output transistors when in reality there are only 3. The output bus in the schematic below shows 33 milliohm 2-watt resistors connected to the emitter of each output. I physically identified that output bus and connected the negative probe of the voltmeter to it. Now we are ready to measure and set the bias for the left channel. Going back to the service manual, it continues by stating to adjust R9 and R41 for 380 mV plus or minus 100 mV. On the schematic, these potentiometers are labeled RP1 1K for both the left and the right channel. However, R9 and R41 are the only potentiometers on the control board of the amplifier, so they are not hard to find. We are now connected to the left channel to look at and set the bias. As you can see, we are over 500 mV. Let's adjust it down to 380 mV. These pots are a little sensitive, so 381 mV is fine. Now, we are set up and connected to the right channel to look at and set bias. As you can see, we're also over 500 mV. Let's bring that down near 380. We will leave it at 384 mV. Again, per the service manual, the spec is plus or minus 100 mV. We are only a few millivolts off. The bias is now set. Now we are going to look at the output with an oscilloscope with no load. We can see how to do this as brought out in the service manual under C500 test point 3. It states, connect a signal generator set to no output to the left and right inputs on the C500. Connect AC voltmeters and dual trace scope to speaker terminals as shown below. We see a simple wiring diagram and then it states, make certain to observe this connection because the floating ground of the lower right speaker terminals. Let's stop right there. The Carver C-500 has the phase inverted in the right channel to be able to bridge the amp in a mono, in theory doubling the power. Obviously, if the speaker negatives were grounded, that would not be possible to do normally, except to invert the phase externally and then connect across both output positives. Internally, that phase difference is rectified by switching the output leads around and making sure the ground is floating. Also, upon looking at the drawing in this picture and the physical layout, we have discrepancies. The red and black speaker terminal is marked on the diagram as left channel. However, as you see on the amp itself, the red and black terminal is the right channel. So I do not trust the wiring diagram, and if not wired right, you could damage the amplifier. I decided to just wire the oscilloscope channel 1 to the left side and channel 2 to the right side. Yes, this makes both channels in phase, but for this test, I think this setup is adequate. This is a simple test to see if clipping is within spec and that the waveform is symmetrical. That's all. We are now connected and ready to test. Let's raise the output of the signal generator. Let me adjust the left channel to match the right. As you can see, raising the output of the amplifier above 57 volts causes what I call a weird clipping in the left channel, which is in yellow. But spec calls for a minimum of 45 volts. That will develop 250 watts into 8 ohms. So 57 volts is well above that, and both channels are fine at 57 volts. There are other tests which are important. For instance, what is the distortion levels at full output into an 8 ohm load? Also, what is the actual power at full output under load? I do not have a distortion analyzer, but I am working on that. As far as the load, my load resistors came in when I was shooting this video, and I will be building a 400 watt 8 ohm load to test my amplifiers. I have more powerful amplifiers we'll be getting into in the future, and I will need to at least double the capacity of this load to be able to test them. I do not want to leave you without the reward for watching all this. Here is the amp connected to my JL Audio 15-inch subwoofers in the formal living room. I am using it in my Dolby Atmos home theater system as a subwoofer amp. I can't play music due to copyright infringement, but I am running my signal generator in it at 40 Hz. Hopefully there's no copyright infringement on that. Output is set to 100 watts per channel, but these speakers are 4 ohms, so it is actually 200 watts per channel. It is quite loud, and I do have some rattles I need to fix. Well, that's a wrap for this episode. Like I mentioned earlier, I have a number of amplifiers that I'm going to be working on. I have a Phase Linear 400 Series 2, a 700 Series 2, and a D500. All of those amplifiers I either want to repair or upgrade. If you like this episode, ring the bell, subscribe, and like. I would appreciate it. Thank you, and we'll see you on the next episode.